So the problem we will deal with is the number 3 problem in the test. Two identical cannon both fire projectile of mass m at speed v0. One cannon is placed on the ground and the other at the top of a tower of height h, above the other cannon. The two cannons are aimed directly at each other so that the lower cannon makes the angle of theta with the ground as seen in the diagram. Surprisingly, if the cannons are fired simultaneously, the projectile will collide. So the first question is how much time delta t passes before the collision. Your answer should be in terms of the non-variable stated in the problem and a physical constant. So the first thing we need to do is like when two cannons fire and when they collide, the y component of the y component should be equal when they collide together. And the cannon from the ground fire at the trajectory route, and the cannon at the other end, which is on the top of a tower, goes through the trajectory route 2. So they will collide in this point. So we separate this problem into two cases. So the first case is according to the ground. So according to the ground, v0 is this direction, and in order to know the y component of this velocity, we need to use cosine v theta. So the v0y, which means velocity is a y component, equals v0 times sine theta. So it gave us the velocity of the cannon fired in the y-axis. And then we will use a formula ry equals the ry final equals ry initial plus v initial velocity in the y direction times delta t plus 1/2 times f net over mass times delta t squared. So this is the position formula that we will use in this problem, and the y means that we only consider the position velocity in the y component because y component will be equal when the two cannon fired when the two fire collide. So then so final position in the y direction equals ry initial plus viy times delta t plus 1/2 times negative mass times gravity divided by mass times delta t squared. Since F net equals, since the only net force on the cannon fired is only the gravity, so the net force will only be the gravity, which I convert the F net to the negative mg. And then we simplify the formula. So ry final equals ry initial plus viy times delta t plus 1/2 times negative g times delta t squared. And then we will put this equation for that right now. And then we consider another case, which is according to the tower. And at this case, the velocity in the y direction is negative velocity 0 times sine theta. Since at the tower the vector of velocity is in the negative direction, so we add the negative sign to it. And since we only consider the y direction, so in order to get the y direction of the velocity 0, we use the sine theta to get the velocity in the y direction. And the same formula that we use for this case, so Ry final equals Ry initial plus VIY times delta t plus 1/2 times F net over m times delta t squared. Since in this case the net force on this one is also the gravity, so then we will convert the F net to the negative mg, which the whole equation will be Ry final equal Ry initial plus VIY times delta t plus 1/2 times negative mg over m times delta t squared. And then we plug the initial velocity in and simplify the equation, and we will get Ry final equals Ry initial plus So the initial for the position will be the height. So it will be Ry final equals h minus v0 times sine theta times delta t minus 1/2 g times delta t squared. And since in the two cases the y component is equal, so we will put the two formula together. So it will be Ry initial plus VIY delta t plus 1/2 negative g times delta t squared equals h minus v0 times sine theta times delta t minus 1/2 g delta t squared. And in the left is the case for the ground, and the right equation is the case for the tower. Since on the left equation, since the initial position is on the ground, so it will be 0. And we plug the velocity in the y direction in, which is v0 times sine theta. So we change the equation to v0 times sine theta times delta t minus 1/2 g delta t squared equals h minus v0 times sine theta times delta t minus 1/2 g delta t squared. And in this case we cancel out the negative 1/2 g delta t squared, and we put the negative v0 sine theta times delta t to the right side, and we will get 2 times v0 sine theta times delta t equals h, and the delta t equals h over 2 times v0 times sine theta. And this is the answer for the part A.